So Chapter 9 is properties of transformations. We're just going to cover 9.1 today. It's translating figures. Okay. When you translate a figure, we'll use a vector to translate the figure. That's our objective. Okay. Translating is the same thing as just sliding something over. So if I took this desktop, and I started here, and I moved to there, that's a translation. That's all there is to it. It's the same size, same shape, right? It just moved to a different position. That's a translation. The direction and distance it moved is how the vector component of it. That is the vector that it moved on. How far, what angle, and what distance it moved. You guys, I'm sure you don't want to do any volume problems since we just took the test on that. That's what that warm-up was. Okay, so let's define translation. A translation moves every point of a figure the same distance in the same direction. Moves every point of a figure the same distance and in the same direction. Image. The image is a new figure formed by the translation. The new figure formed by the translation. So the image is the new figure. What you started with is the original figure. That's called the pre-image. Okay, so it's kind of, you usually think of the image as the first thing you take the picture of. But it's not. That's the pre-image. What you start with is the pre-image, and then what it moves to is the image. Isometry. Iso means equal. Metry means size, or length, or measure. So a transformation that preserves length and angle measure is an isometry. A translation is an isometry. Is that your phone? Why don't you put that away? All right. Graph the quadrilateral ABCD with vertices as given. Find the image of each vertex after the translation that takes the points x, y to the points x plus 3, y minus 1. Graph the image using prime notation. So what that means is, okay, so this is the original, would be the prime. So how I would do this, I would have like A, we'd have point A, that's negative 1, 2, and I take it to, I'm going to add 3 to the x value, and I'm going to subtract 1 from the y value. So we have A prime is equal to 2, 1. Everybody see how I did that? I subtracted 3, I added 3 to the negative 1, because that's what it told me to do, and then I subtracted 1 from the 2, and I got 1. You do that for each point. So B is going to be negative 1, 5, which is going to be B prime, is going to be, we add 3 to that, 2, we subtract 1 from 5, and we get 4. C. C, we have the point 4, 6. All right. And C prime is going to be 4 plus 3 is 7, and 6 minus 1 is 5. That's prime notation. Okay? So does everybody have that? All right, now here's how you graph it. What it would look like on the graph is, okay, so it takes us through the steps I just did. And then when we graph that, oh, there was a point D. I didn't do the point D. Yeah, D was 4, 2, and it took it to 7, 1. You'll want to write that down as well. And then, so the prime notation part of it is, so your original point is labeled A, B, C, D. And then after you translate this, move every point positive 3 in the X direction, down 1 in the Y direction. Then these new points are going to be A prime, B prime, C prime, D prime. They're going to be primed. Any questions? All right, next example. We have a triangle RST with the points as given. Find the image of each vertex after the translation. X plus 1, Y plus 2. Graph using prime notation. Do that one on your own. Go ahead and do that one, and then I'll put the answer up. Yes?
Does each different shape have a different prime notation? Because in the first one it was x plus 3, y minus 1, and in this one it's x plus 1, y plus 2.
Yeah, these numbers can be anything, it varies.
Okay.
It's just this specific example, you do that.
Okay, so that'll, like, the prime notation, like, it'll be on the question.
Yeah,
so you
yeah.
don't have to, like,
Right.
consider it. Okay.
You don't have to memorize it. It'll be, they'll give you that in some form or the other, what that is. All right. So let's see. Here's the solution. Your values of your points are as follows. You should have gotten those for your points. You're adding 1 to the x and then adding 2 to the y. And then your graph, okay, of this is going to look like the starting triangle is your red triangle, the ending triangle is your blue triangle. So the vector that represents this, you don't have to put it on the triangle, so it's the vector representing this translation could be represented with this line right here. It's going over 1 up 2. You start it at the origin, go over 1 up 2. That's the vector that I apply to each corner of this, each vertex. That up 1 over 2, up 1 over 2, up 1 over 2. I mean over 1 up 2. That's what I'm doing each time. All right, any questions on that part? Okay. Now, the image of xy, with the translation of x plus 4, y minus 7, the image, so this time we know the result, p prime, q prime, with endpoints p prime, negative 3, 4, and q prime, 2, 1, find the endpoints of the pre-image. How could we do this? What would we do with this translation? What am I going to do to this x value if I want to find the pre-image? Megan?
Would you subtract 4?
Yes, you do the opposite. So we would subtract 4 and add 7 to these points. Because that's the result. I got to this point from adding 4 and subtracting 7. So if I want to get the original, I would subtract 4 from the p prime and q prime and x values and add 7. So it's going to look like we would have p prime is negative 3, 4, and it translates to the pre-image of p would be, so we subtract 4, that would be negative 7, and we add 7, negative 7, 11, and q prime would be, we start at 2, 1, and we subtract 4, and we get negative 2, and we add 7, and we get 8. Everybody see what we're doing there? Everybody follow that? Yes?
For p prime, isn't negative 3 plus 4 just 1? Not
But you're subtracting 4.
oh.
We're going backwards because this is the result of doing this.
Oh, okay.
This is the image. We want the pre-image, the starting point. We want this. So to get from here to there, I subtract 4 and add 7. You just have to read what it's telling, what it wants. All right, everybody have that? Okay. So there's our solution. We already had that. Okay. Write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime, then verify that it's an isometry. Okay, so here is the graph. We have to come up with the rule. So we've got XY is going to go to what? What's it going to go to? If we go from C to C prime, what do we do to the X value? What are we doing horizontally? Sydney?
Subtracting 4.
We subtract 4. And the Y value, we do what?
Plus 1.
We go up 1. So it's XX minus 4, Y plus 1. That's it. And then to verify that it's an isometry, you just have to see the sides are the same length. C prime, B prime is 3. CB is 3. A prime, C prime is 2. AC is 2. That's the same. And then this diagonal, you could do the Pythagorean theorem, or you can think of it as it goes down 2 over 3. This one goes down 2 over 3. So that's got to be the same length as well. All right. Any questions there? Okay, good. All right, now vectors. This is the same thing. It's just another way to express a translation. But let's define a vector. A vector is a quantity that has both direction and magnitude. It is represented by the coordinate plane by an arrow drawn from one point to another. The initial point is the starting point of the vector. The terminal point is the ending point. Okay, so a vector is going to look like, a vector looks like this. You just draw an arrow. It's like a ray, okay? But yeah, the arrow is important because it tells you which direction you're moving. Everybody have all that? All right, moving on. So component form combines the horizontal and vertical components The horizontal component goes left to right. Vertical component goes up and down. All right. So name the vector and write its component form. All right. So component form. So we would name the vector. You put the initial point first. So the B comes first. And then the point it goes to comes second. So if I name this vector, it'd be BC, and you put a little arrow symbol above BC. It just has one little part on the end instead of two. That's the symbol for the vector BC, starting at B, going to C. And then the vector component form is you just, you use, instead of parentheses, you use these angular parentheses. And then you just, for the first value, the x value, you put how far horizontally it goes. If it goes to the right, it's going to be positive. The number would be positive. If it went left, it'd be negative. It's going right this time, so it's positive. So it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes over 9. Did I count that right? Yeah. Okay, so the first letter would be 9. What would the second letter be? Yeah, it goes down 2, so it's 9, negative 2. That would be the component form of that vector. Now, this is the same thing as saying this. XY goes to x plus 9. X plus 9, y minus 2. That's this and this are saying the same thing. Yes?
Would you put the BC for it, or just the 9-2?
The component form?
Yeah.
Let's see in the next slide how they do that. Does everybody have the idea? All right. So here's how you express that. Okay, so there they just said, okay, so when you put them together, let's see. We've got, so name the vector and write its component form. So if we name the vector, how am I going to name this vector? Yeah, Tx. So it's Tx. Come on, John. So Tx vector, and the component is going to be, what's the x value going to be? 0. Y value? 3. I just write it like that, Kayla. There's no, you don't put equals or anything like that. You just put it like that. Put it before it, yeah. Any questions on that one? Okay. I think this is the last example. Then, okay, this is extra practice. I don't think this is in your notes, but let's go ahead and do this one. So how would I name this vector? Yeah, ST. And the component form would be what? Yeah, -8. Good, it's negative. And then the y value is 0. Got it? Okay, good. All right. So, they give us the vertices of L and M, and we have to translate it using the vector -2, 6. Okay, so I would have L starts out at 2, 2, and when we translate it, what does it become? The x value is what? 0. We subtract 2 from 2, 0, and the y value is 8. We add 6 to 2, so it would be 0, 8. Okay, M, we've got 5, 3. What does M become? 3, and then 8 plus what are we? 6 plus 3 is 9, so 3, 9, and then N is 9, 1. Okay, we subtract 2, it becomes what? 7, and what's the y value become? 7. Yeah, 7, 1 plus 6 is 7. 7, 7. Questions? Everybody's got it. Okay. All right.